Welcome to Module 7. We're going to be doing protocol analysis. There's nothing really to say other than this one's going to hurt. Module agenda, we're going to have a quick review of just some concepts you should know before going to this that we've covered in previous modules. We'll go into Section 2 for header analysis. Section 3, we're going to redo Section 2, but we're going to do everything in Wireshark. And Section 4, we're going to cover some attacks seen in PCAP so you can get familiar with those. All right, Section 1, a quick review. First, we're starting off with a slide here for covering the old saying, PCAP or it didn't happen. This module is all about protocol analysis, so of course we're going to be discussing packet captures and the tool of Wireshark. So backing it up a bit, if we're doing network traffic analysis, if we're doing protocol analysis at the most granular layer, PCAP is going to help us identify those protocols that are in use, and looking at the actual bits over the wire for every single packet that's traversing, that is where the proof is in the pudding. It's always going to be in PCAP, which is why we say, show me the PCAP or it didn't happen. Because if you can't see every single bit going over the wire, how do you know it was really there? PCAP analysis allows you to get the most granular detail you can out of the network. It's a great capture tool for, like, if you're using Wireshark or TCP dump to collect your PCAP files. You can do some troubleshooting. You can pinpoint anomalies. You can identify suspicious network activity. You can use this in forensic investigations. And of course, PCAP can also help you with compliance. So it's basically just a way for us to see all the data being transferred over the wire through running a tool like Wireshark, which is a network protocol analyzer to collect PCAP files from. So speaking of Wireshark, we just said what it was. It's a network protocol analyzer to capture, analyze, and interpret network traffic seen in real time. If you've heard of Wireshark, chances are you've been over to Udemy or YouTube and you've seen the packet head, aka Chris Greer. He is a phenomenal instructor for teaching Wireshark and getting really in-depth analysis skills with Wireshark and packet analysis. Definitely would check him out, and I would go through his Getting Started with Wireshark course available on Udemy. I've gone through it myself. I think it's great. And Wireshark is a free tool that you can use and download today for $0 and leverage YouTube and start learning it. So it's a very user-friendly interface. If you've done Rangeforce or TryHackMe or any type of free platform that gives you modules, I'm sure they have some modules in there covering Wireshark. Common traffic we've learned about. If we're thinking about everything that we've discussed in previous modules, we've covered so many protocols on the left there. Now we can kind of see on the back end the traffic traversing the wire through PCAP. We're going to get into header analysis, which is Section 2. There's different headers based on how your packets are being encapsulated and brought up or down the OSI model. Remember, we said if data is traversing up the OSI model, the packets are being encapsulated and more data is being thrown on to the packet to make it larger. More headers are being added on as the data is being ready to be routed up the OSI model. And when the data comes back down the OSI model, these headers are stripped off so that each layer can be reading each packet as it's applicable to whatever header needs to be read for that layer of the OSI model. So there's a lot of different headers that we're able to see. We're going to cover a few of the main ones that I think are important, but definitely go and explore other headers that are out there. Do a quick Google search for DNS header or HTTP header, and it will give you the chart for what the header looks like and the information contained in it. We're going to cover the Ethernet header, IP version 4 and version 6, TCP and UDP headers, and ICMP headers, and I think a few more in Section 2. But basically, the header is what's telling you what's in each section of that header and what each bit is allocated for in byte format. So we're going to get very familiar with that in the next module. Okay, a bit of review here, as it is important to review the concepts of a bit. So a bit was either a 1 or a 0. A byte was 8 bits. So any combination of 8 bits gives us 1 byte. Hexadecimal, this was base 16 notation, whereas binary is going into base 2 notation, and then our decimal values, what we've grown up with our whole life, that was base 10 notation. We covered this all the way back in module 1, and we covered how to convert from binary to decimal, decimal to binary, hex to binary to decimal, etc. So you need to have those skills already understood before you proceed with this module. And hexadecimal, we also covered, is denoted here by the prefix of 0x. So that byte in hexadecimal would be written as 0xEE, with 0x being the prefix that we use to denote a hexadecimal notation. If we take a look at converting A9, remember we broke these out into 8, 4, 2, and 1, and we broke 9 out to 8, 4, 2, and 1, and we were able to convert the binary backwards to give us this string of 8 bits. Again, a quick review, we went from A, B, C, D, E, and F, with A being the value of 10 and F being the value of 15, and that is the max value you can have from a range of 0x00 giving you 0, or 0xFF at the max giving you the max value of 255. It's also not a coincidence, as this screenshot is taken from Wireshark, that the first section here, before you kind of get to this space separation, you have 1, 2, 3, 4, 5, 6, 7, 8. 8 bytes on the left, and then you have another 8 bytes on the right. 8 and 8 gives you a total of 16. Remember, hexadecimal, base 16. Is this a coincidence? No. It's so that it's easier to read in the chart, and when you get into identifying common locations or IP addresses, like I can already spot right here, this C08A, if you were to convert that out from hexadecimal to binary to decimal, this would be 192.168. So I know this is the first 2 bytes of an IP address, and the IP is actually converting this .1 to then whatever 43 is in hexamal to a decimal value over here. So it gets a familiar placeholder for why it's 8 bytes over here and 8 bytes over here, and it should make sense that if this is an 8-byte IP address, 8 times, or sorry, it's 4. 4, a 4-byte IP address, this is going to be a 32-bit IP version 4 IP address. Remember, we're going to highlight this stuff as we go through the modules. And if you remember from previous modules, we've always been trying to be redundant with, 32-bit IP version 4, 128 IP version 6 address, 48-bit MAC address, etc. These concepts are now going to be layered on heavily in this module. So we've also talked about ASCII notation. You'll just have your ASCII over on the right. But definitely very important to make sure you have a strong understanding of bits, bytes, hexadecimal notation, and regular decimal, because we're going to start converting these and breaking these out, and remembering that this is 4 bits, this is a different 4 bits, because these are going to have different values when we start getting into header analysis and different meanings associated to them, and you need to understand where the splits are occurring at each bit notation separation.